Problem, we have Stacy riding her bike to the train station at 15 kilometers per hour. So she rides at 15 kilometers per hour. Every day she passes the bagel shop at the same time that the train does. One day she had to fix a flat and was 45 minutes late, and the train passed her 15 kilometers from that bagel shop. In how many minutes will the train reach the bagel shop? So she is going towards the bagel shop. She's starting here and then going somewhere. We don't know eventually where she's going, but she is starting somewhere and then ending up at the bagel shop, or at least crossing it. And that means that she starts out here at 0, right? This is our start of our run. And we can consider that for the train as well, because we don't know where the train's coming from, but we're looking at this chunk where she starts and the train starts. We're at 0 hours. And as they go along, they both reach the bagel shop at some time. So this time is for both the train and for Stacy. And that's this time right here. And then in this new situation, this new day, she's a little bit late. She starts off, maybe fix that with a line. She starts off late. So her time, when she begins, it's not her usual run. So we can say that instead of starting at 0, she's starting a little bit later, right? The train's still going to pass at the 0 point at the same time, but she's actually late. So her time is now, it's 3/4 of an hour, because she is 45 minutes late, and that is 3/4 of an hour. But I don't need that H in there yet, that'll just confuse me. So here, time equals 3/4. And we're dealing with hours. And then she's going along, and because the train's on time, it's going to pass her before it gets to the bagel shop, which means that both she and the train, so Stacy and the train, are both going in the same direction, because if she's riding along towards the bagel shop over here and the train passes her and hasn't gotten to the bagel shop yet, that means the train's also going in the same direction. So they cross here. So the train overtakes or passes Stacy here. And then in the end, the train again is going to arrive at the bagel shop at the same time. T of A equals A. We don't know yet what time Stacy will get there, but we know the train will get there at the same time it always does, right? The train's not altering. Anyway, so the last piece of information we're given, we have that she was late. That's 3/4 of an hour. But here we say that the train passed her 15 kilometers from the bagel shop. So if this point is 15 kilometers from the bagel shop, this chunk of time can also represent 1 hour, because we're looking at as the bike goes along. We don't know what it is for the train, but for the biker, she's going along at 15 kilometers per hour. So we can say that this chunk, this distance right here, is 1 hour. Right? That's her speed, 15 kilometers per hour. So for her to cover this distance, the distance of 15 kilometers at her constant speed, it would take her 1 hour. And also we can think about these other chunks of time here. We have the total time still as A. We have this time right here is 1 hour. And that means also that this time right here is the total A minus the 1 hour. Gives you this chunk. So the whole thing, right, from here to here, this whole line, you take this purple part out, you have the red left over. So the whole thing is A minus 1 hour is this time. And then where does the train overtake Stacy? Well, it's going to happen at 3/4 of an hour plus A minus 1. Because the train's going along and Stacy's going along in this direction. They're riding. And our distance from here to here, I mean, we don't know what it actually is, but we know that the starting point is 3/4 of an hour because she's late. So we do 3/4 of an hour plus this distance, A minus 1, will take us exactly to the point where the train overtakes Stacy. And at this point, I think we have enough to solve this problem of this bike rider and this train who are going in the same direction. Well, altogether, the train is still traveling at 8 hours. So that's what we know. That hasn't changed for the train. But the time, right, equals A. If we say the time is A minus 3/4 of an hour plus a minus 1. Well, this tells us that the time at A minus 3/4 h plus a minus 1. So basically, this whole chunk, sorry, I blanked out there for a little bit, this entire chunk, A, that's the first part of our equation. We're saying that whole thing minus this from the overtaking point back. So basically, from 3/4 of an hour all the way up to exactly the overtake point. If you take all this away, what's left is the little chunk that we're looking at, this green part right here. So the whole thing minus this color, this gets like a maroon, gives you the green time distance. And that's interesting. With such little information, we could say that the time, well, we know the whole time is equal to A. We know that this time is equal to from 3/4 plus a minus 1. I can cross this hour out for now. And that means that the whole thing minus this will give you this time right here. And we don't really know much about it, but we can figure it out. So now, what do? Well, let's distribute this subtraction sign. By thinking A, we're subtracting 3/4, we're subtracting A, and we're subtracting negative 1, which is really just plus 1. And then we have A and negative A, so that those are opposites, then they add to 0. So T is going to equal, I'm going to switch the order of negative 3/4 plus 1 to 1 plus negative 3/4 of an hour, right? This is all hours and time that we're dealing with. We're dealing with time. So what is 1 plus negative 3/4 or 1 minus 3/4? It's 4/4 minus 3/4, which is equal to 1/4. And we're dealing with hours, that's 1/4 of an hour, which means that the train will arrive at its bagel shop, as it always does, 25 minutes after the train passes and overtakes Stacy. That's this green chunk right here. This time it's 1 hour for her, but it is 25 minutes for the train.